Hello everyone, today we're going to graph some square and cube roots, and we're going to do this with a little bit of like exploration. So hopefully you understand that we're starting with the same parent function every time and we're just going to move them around. So you just need to learn how to translate functions, which you've seen before. We just got to apply it to cube and square roots. As a little refresher, let's find the inverse. So for inverses, you're going to flip x and y. This says f of x, we're going to call that x, that's our output, and we're going to make that our input. And then we're going to say the cube root of, instead of x minus 2, it's going to be y minus 2. Now the goal here is to get y by itself, and then we'll have the inverse function. So to get y by itself, first we'll subtract 3. Now on the left side you have x minus 3. And on the right side you have the cube root of y minus 2. To undo cube rooting, we're going to take the reciprocal of 1/3, which is 3, and we're going to cube both sides. I'm not going to expand that. I'm just going to leave that as x minus 3 cubed. And on the right side, now I have y minus 2, what's under the radical. Last step to get y by itself is add 2, x minus 3 cubed. Now I'm going to say plus 2, and that's y. But since we're finding inverse functions, once you isolate y, I like to write that as f to the negative first. That's read as the inverse of f. So the inverse of f is right here. That's x minus 3 cubed, and here is the original function. It's got a cube root in it. So these are inverses of each other. You flip x and y, and you solve for y. Let's talk about parent functions. If you're going to graph square roots, you should use perfect squares. So the first 3 or 4 perfect squares are 0, 1, 4, and 9. Okay, the reason I'm picking those is because when I want to graph this, I want them to be nice. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. This is called our parent function. All of the graphs that we do are going to come from this one, so let's plot it 0, 0, 1, 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 2, and then 9, 3. So if this looks like a parabola on its side, it's because it is. And if you were to reflect that, you would get the rest of the parabola. But for square roots, you have half of a parabola so that it is a function. That's our parent function for square roots, and we're going to practice translating that in a second. Let's do the same thing with cube roots. Perfect cubes. Now, these can be negative, so this is a little different. We're going to do -8, -1, 0, 1, and I'm also going to throw in +8 in there. Then we'll take the cube root of those. The cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. So then what's the cube root of -1? -1. The cube root of -8 is -2. So this one looks a little different. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Okay, this goes on forever in both directions, and it has a little curve to it in the middle, like that. You cannot square root a negative number, but you can cube root a negative number, because if you have an odd amount of negatives, 2 of them will always cancel out, and you'll be left with 1. So 2 times 2 is 4, and 4 times -2 is -8. That's why the cube root of -8 is -2. There's our parent function for our cube root. So what we're going to do now is let's talk about moving stuff around, and I've got a little Desmos sketch here. So it's supposed to be x minus h plus k. And I'm going to say I want h to be -2 and k to be +3. Okay, so this is what we're actually graphing. I'm going to show you. When I have square roots, if I make h -2 and k +3, what you need to realize is that's moving it left 2 and up 3. So when you see x plus 2, that's what that means. That's going to move it left 2, and on the outside, up 3. So let me show you how these work more generically. H, as you move h left and right, it moves the function left and right as I move this slider left and right. But what is tricky is it's x minus -5. So this is the graph of x plus 5, the square root of x plus 5. Okay. And over here, if I did x minus +5, this is the graph of the square root of x minus 5. So h moves it left and right, it's kind of backwards, and k moves it up and down. That's pretty normal. So if I do cube roots, same idea, the cube root of x minus 3, and then I'll say -2. X minus 3 is going to move it right 3, down 2. So if I make h3, I'll do it with cube roots. h3, 1, 2, 3, goes right 3, and then k is -2, right 3, down 2. We're going to make all of our graphs based on the idea of translations, and notice they move the same way. All functions move the same way. Okay, if you want to see, I'll just make up a function. You know what? I'll just do like something crazy. A log of x minus h plus k. Watch what happens. It moves left and right with them, and it moves up and down with them. It doesn't matter what function I pick, they all have the same behavior. Okay, so when we graph these, I'm going to start with the same parent function I already generated, which was 0, 1, 4, 9, 0, 1, 2, 3. But now, if it says x minus 3, hopefully you realize that makes it go right 3, and on the outside, up 4. Well, if you move right 3, that's only going to change the x values. And if I want to go to the right, I want the x values to be bigger. So I'm going to go this way. So I'm going to take these x values and I'm going to add 3. So instead of 0, 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. And 9 plus 3 is 12. If I want to move it right 3 in the table, I would add 3 to the x's. If I want to go up 4, I would add 4 to the y's. So 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. And 3 plus 4 is 7. Let's plot those points. 1, 2, 3, 1, 2, 3, 4, right there. That's where I'm starting. 4, 5, 7, 6, and lastly 12. I'll just kind of put a couple extra tick marks there. 12, 7. So this looks like that. That's the radical. The domain. So for domain, since we started with 0, you can't plug in -1 because the square root of -1 is imaginary. So the domain, the first x value here, oops, that didn't work. The first x value is when x is 3, and you can see that's not going to happen right here. You could just say, look, x minus 3 has to be greater than or equal to 0, so the domain is 3 to infinity. The smallest x value is 3, and it goes forever to the right, and 3 works, so we use a bracket, because 3 gives you 0. 3 minus 3 is 0. The range, the smallest y value here is at 4, and then it goes up forever, so 4 to infinity, and again, 4 is in a bracket because it hit the first point that it hits is 3, 4. You can see there's a 3 right there and a 4 right there. Okay? That's a square root. So we're based on translations. Cube root, we're going to do the same thing, -8, -1, 0, 1, and I need to add a column for 8, or a row. The cube roots are right there. We're going to do the same thing. X plus 5 moves it left 5, and then the -3 moves it down 3. So if you go left 5, you're changing x values. Left, subtract. -8 minus 5 is -13. -1 minus 5, -6. 0 minus 5, -5. 1 minus 5 is -4, and 8 minus 5 is 3. So subtract 5 from your x's to go left 5, and subtract 3 from your y's to go down 3. -2 minus 3 is -5. -4, -3. You should notice a nice pattern here. -2, -1. And that's always going to happen for these because we picked those numbers to be nice, so they should be nice. So when we draw this one, -13, I can't get that one on here. It's like that somewhere. -6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, right there. -5 is at -3. -4 is at -2. So you get this Orion's belt kind of thing here. Let's see. 3, -1. 3 -1's right there. Okay. So we have our parent function for our cube root. We've moved over, and it looks like this and something kind of like that. So that's our cube root after we've translated it. Left 5, down 3. So what I mean is we started with the cube root. That was the parent function, and we left 5. 1, 2, 3, 4, 5, 1, 2, 3, and that puts you right there. You move the whole function. So you can see how this one's still at 3, -1, even though I just moved the whole thing? Pretty cool. If you can remember the parent functions for square root and cube root, translating them should be very straightforward. So for the domain for this one, it's all real numbers. It goes forever left and right, and the range goes forever left and right. You can't break a cube root function. So these are all real numbers. Okay, and that's going to be all cube roots. So you need to do a couple practice problems. You need to smash that like button, and you need to smash that subscribe button.